Hey everyone, welcome back to the channel. Today we are diving into something really exciting. We are going to explore real movie industry data and walk through a full end-to-end analysis together. Real numbers, real insights, real storytelling. And the best part, this data comes straight from Kaggle. If you're new to Kaggle, think of it as a playground for data lovers. Thousands of open data sets, real-world projects, a place to learn, grow, and build your skills. In this tutorial, we will start from scratch. We'll clean the data, build the new metrics like ROI and profit, spot the trends, and uncover the hidden stories. Short, clear, practical, whether you are a beginner or a pro, this is for you. So grab your coffee, open your notebook, and let's break down the numbers behind the big screen. So here we are today. The first thing we're gonna do is open a new file we created. Let's call it Movie Industry.IPyMB, which is it's a Jupyter notebook, and I'll select the kernel. I already have a Python environment selected. I'll use this one. Then let's start with the title. Let's create a title for this. Maybe one movie data set. Let's call it end-to-end analysis script. I think that's a good title. And then we can go to the code. Oops. Should be here in the next line. Then let's add another. Let's keep this organized. Let's keep this organized. Let's do number 2, set up and load. That'll work. And then we'll start with the code. The first thing we're gonna do is import all the libraries. We're gonna import everything we need. So let's start with import Pandas as PD. I think that's one of the first we have to import. Then the IntelliSense or the Copilot version, which I'm gonna see if I can turn it off today. Manage chat. Well, I don't see where to, but I know there's a way how to turn it off. Let's keep going. So from Matplotlib, import. That's another one that we like. I like to import it. The Matplotlib library. Import matplotlib.pyplot as PLT. Another one we will use is, of course, we will use import Seaborn as SNS, and then we can import matplotlib.ticker as let's not import the ticker. Let's do it different. From matplotlib.ticker import. Let's import the font formatter. That way we can do some formatting on the charts in the future. Something I like to do, and it's just because I sometimes will just look at, at just the head, just to look for the 5 first rows, the 3-4 first rows, or we look at the samples. But I like to, just in case, I like to do this, and some people, they don't know this, but you do set option dot open parentheses, you do display.max columns, none, and then I like to do the same for set option. I think I did an asterisk here, it doesn't go here. So it's display.min max rows. And then we do none because, you can set a parameter there saying I only want to see limit to certain rows, but we want to see everything. We won't see everything as we go, but I just want to show you what that does. And then let's add the path. So for the path, let's add a comment here. We can say update this path as needed. Yeah, that will help. And then from there we can do data frame is equal to PD read CSV, because we get that from Kaggle. And now here's something. Some people, they like to use the library OS or system. I like to use the path version. I think it's straightforward. I like better. So I use path, and then I add the strings here in the middle. Let's see, I copy here somewhere the location for my data set, and it's here. So I think that's where the file is. And then just for a check, we can do df.head, and then, well, we have all the data. Now I want to show you what happened if we don't have this option. Okay, let's say I want to see the entire data set. I just have to do a df. And boom, we have the entire data set. It's large. If we don't do that, what will happen is that, let's say we are going to, so if I do this, the data is going to be trunk. Well, we have all the data now because I already read everything, because I set the format already for this. But yeah, if we don't do this, what it will do is it would truncate the data. Now we are able to see all the data because the file has been loaded. The only thing is, if we don't want, we can just short it to the head, or do the first 5 or the first 10, and there's our data. Perfect. So we don't need to look at that. We are good. So we import the libraries. We configure the display settings to see to display all the max columns and the max rows. And then the third thing we did is we load the data set. So we have the data set. We can start working. The first step I like to do, it's like I said, I show you in the step before, but I like to keep an idea of how my data set looks like. And I do like, okay, 3 rows should be fine. So I can know that we have name, rating, genre, year, release date, score, vote, director, the writer, the star, the country where it was recorded, the budget, we have gross, we have company, and we have the runtime. Let's keep, so we have the data set load, like I said. Let's start now. Let's create another title and add it like, let's start with maybe data cleaning and normalization. So we have the data cleaning and normalization. We will start with a code writing. The first thing we're gonna do is, it looks clean to me. I mean, there's no issues with the columns, so I could avoid this step, but it's kind of, I like to do it. So the first things I'll do is I'll normalize columns for easier handling. Sometimes we have different names, different things. The intelligence, it's giving me kind of a patterns. It's good, but because we are learning today, I'll just go, I think my code's a little shorter than that, so we can do define data frame columns equal data frames columns dot string. Then we can do a lower, which all them, they are lower, but like I said, it's just to make sure all the data is aligned. And then I'll do, as soon as I get the lower, I get string again dot replace. And what we're gonna do in the future, we don't have in this data set, like I said, but in the future, if we have any space, we will replace it with the underscore, and that will give you this nice formatting that people call snake formatting, which is really good. And then I'll move to the next cell, and then let's start working on numeric. So we see here that we have genre, we have score looks good, we have vote, we have director, writer, we have budget, we have gross, and we have company runtime. So let's start with those. Let's start for column in, let's do it little comment here, normalize numeric like columns. Then start with for column in, let's start. So we said we have votes, we have budget, we have gross. What else we have? We have score as well, and we have a runtime. But I think that those are the main ones. So I'll close, open, and then if column in df.columns, then it's where we start. So define data frame.columns, column equal, then we will do, let's open parentheses here, and then start with data frame.column. And then from there, let's do, just to keep it short, let's type, let's do, type string. And then from there, We can do another one, string dot replace, and then from there, what we're gonna replace? We're gonna replace any wrong formatting that they had previously. Sometimes some data they come with different formatting issues like slash or dollar or extra commas or something like that. So what we'll do is we use the reject replace, and we will replace this. I could type it out, so I'll type it, that way we get used to it. So dollar symbol, comma, and then we close and we do the quotes, and then other one adds the extra space just in case. We will replace it with clean, with empty or none, and we will do rejects equal true, as the intelligence it's saying. The other thing we can do, we can close parentheses here, close parentheses, and then from there we can do a data frame dot column. Now we are formatting to PD to numeric. Then we will do data frame dot column. I think I added an extra bracket there. So comma errors equal coheres. So coheres, what we'll do is if you get an error on the data, it will just skip it and keep it in null. And then I think that's all. So let's check it out. For columns in votes, budget, and gross, if column in data frame columns, define data frame columns equal data frame has type string. We check that one. And then if it's a string, so we will convert it to string. And then if in the string we have any of this symbol, we will replace it. And then after that, we will define column has a numeric, and we'll convert it to a numeric value. So let's check that out, see if that works. And the easiest way to check this is data frame.head, and it will give us the formatting. It looks much better now. Perfect. Yes. So if we didn't get any errors, means that it's good. So we have the vote is the first one we did. We did a budget. That looks very similar. We can also use here sample just to look at different. Let's do a sample of 5. If you see here, we get an N here for the gross. We're going to be looking at those in a minute. We got budget. We have some N's in the budget as well. We look at votes. So everything looks good. Let's keep going. So we did all our data cleaning. We start doing the data cleaning normalization. We convert what it was numbers. We make sure that they are good. Then let's do something. Let's do quality checks to see all those name cells or rows that we got there. So we'll do data quality checks. I may be spelling it wrong, but I will just to keep organized all the data. So let's go to write a code. And then what we're gonna look here is we're gonna look for missing values like measures. We are gonna drop rows with any NA. We can look for duplicates, detect remove the duplicates, and we can reset the index. Maybe do a categorical normalization for the rating labels. Let's check what we can do here. Let's start with let's check how many null or NA data we have. So I'll do a measure and drop rows with any NA. Then the first thing I'll try is let's look for missing. Let's create a variable here. Values equal data frame that is null. Intelligent is giving me the option there that sum. Let's do it differently. Let's do data frame is null dot any, because we are looking for any, and we are looking in the axis equal 1, and then we're gonna get a sum. So if we display that val, it's saying that we have 2,247 rows or lines that they have missing values for any reason. I like to look at this as percentage, and the way that you can do it as percentage is let's do a missing radio. And something I like to do, even before doing that, I'll create another code here. Let's do a data frame dot shape, and then we can know what the shape is. So the shape, it says we have 7,668 rows and 15 columns. So we are looking for this. It says that 2,247 rows has missing values. The next thing I like to do, this is just because I like numbers, I will do missing radio equal, and let's do a missing val, which is the value we got there. And then from there, we can do a div data frame shape, and intelligence is telling me that, which is right. So what I'm going to do is I'm going to access to this, and I'm going to get the first number. So I'll go to here and 0, close parentheses, and then I'll do that times 100 to get a percentage. So from there, we can tell that, we can say it. Let's use intelligence here. Let's do a print, and then we can do a rows with missing values. Now let's do this, and then percentage, which is good. That looks good. So I did rows with missing values, 2,247, which is a 2930.3. Let's change this formatting here. Let's add a parenthesis here. I like this, and for this I want to do only one. So that gave me a 21.3%. And actually, I don't like this. I'll keep it just in percentage. I like percentages. So yeah. So rows with missing value, 29.3% of the total data. That's good. And this is what's just checking. Then from there, what I can do is I can remove all those. So let's do for a clean analysis, drop rows with any NA values. I like intelligence. So the step here will be data frame equal data frame. We can do the data frame dot drop NA, and then we can do in place equal true, and then we close parentheses. And then if we, I type here something wrong, double P here, that's good. So it says we have row missing values. So if I go here and I do a code here and I do data frame.shape again, you'll see that I have 5,421 and I still doing the 15 columns. So it's good to know that. I know that we remove all the DNAs. That's good. We can continue it. Now that we look for missing values, let's focus now on duplicates. Sometimes the data has duplicate values. So it's always good to check those. So I'm gonna do it duplicates handling. That way you have the idea of what we are doing here. And then let's do a duplicate count equal data frame duplicate, and then a sum. So that will tell me, if you look at here, let's say print, let's do that and see what it does. Duplicates, we have 0. That's good. But we don't know if in the future we want to update this and we want to make it look more, if we are going to have more data and for some reason the data is going to come with duplicates or something like that. So it's always good just to be prepared that way, because you don't want to be repeating the same code every week. So you have a code, you get it, you put it ready, you have it ready. So every week you import the data, you export the data from Kaggle or from whatever resource you have, and you want to import the data to the system to get all the insights. So you don't want to be repeating the code. So it's always good to make these checks. So let's do if duplicate that count greater than 0. That's what we're gonna do. Now it's 0, so we're good. But let's do df drop duplicate. Then we'll do the in place equal true. The other thing we'll do is print. Let's say duplicate rows, remove it. That should help. Then it's always good to do an else, right? So print no let's do duplicate rows found. That sounds good. So if we print it, no duplicates row found, because we didn't have anyone. But like I said, it's good to have those checks. You get the data, you import it, and then every time you check it, you check just in case you have any, extra duplicate, someone by something or someone duplicate a data, which is good. Now, after doing all that, let's add another code here. Let's do data frame .head. Then we have the data there, which it looks good here, but let's do a 50 rows. And if you see 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, but you have here, you see the index jump from 15 to 16 to 17. So one of the good things to do, it's always to reset the index. That way we have a clean index and it's not golden. So what I will do is I create reset index after dropping rows. That will help. And will be the reset index drop equal true, comma, and in place equal true. That should work. Now, if I do a data frame dot sample, I try with 15, that will work. We can see, well, not in sample. In sample, we cannot see because sample, what it does, it picks different rows just to give you a sample of the entire data set. We can do a head, and let's go to 50 again. And then we see that for 15, 16, 17, so we have the index has been reset, which is good. Let's delete this, we keep it, and then we jump to the next one. Let's go to the next one. So after resetting the index, the other thing we would like to do is let's look at the data very quick. Yeah. So we clean everything. We have everything clean. Now we're gonna look at one of the things we're gonna do is we're gonna check the ratings, and let's do a check to the ratings. So let's do a value count data frame dot let's do rating, and I'll do a valid dot value count. And from here, oops, I got an error here, value count. So it's saying that we have R movies, PG-13 movies, PG, G, not rated, unrated. So these ones kind of, they are the same thing, right? And then we have NC-17, TVMA, approved, and X. Let's clean that. Let's start with building a normalize a categorical label. I'm doing this for this one, but you also can do it for all other label columns. So let's do a define data frame, rating. Close the data equal to data frame dot rating, and we will do a replace. From there, we will replace. What will we replace? We will be replacing unrated with not rated. That will give us a very clean overview. Add them together, and then we can close that. Should be good. We don't need to replace anything else. And let's look at the data. Let's do it again. Let's do a data frame dot rating value count. I like that intelligence help you to know what you want to look, and boom, it's gone. Now we have 61 rated, which is the unrated plus the not rated. That gave me a total of not rated of 61. I remove this. I don't need this anymore, or let's keep it, because if I at some point I want to look at how many movies we have based on the rating, that's a good number to know. Now let's start doing some feature calculations, because I see here, let's look at the code very quick. I see here this data that we have budget, we have gross, but there's some data that we don't have, like I'll call it profit. So what is a profit? Profit is gonna be the budget and the gross. So whatever it costs and how much you make for it. So it will be gross minus budget will give you the profit. And I would like to do the ROI, which is the return on investment. And what the ROI does, it gives you a percentage of that profit. So it will tell you you make it 20% or 100% dollars X dollar more than what you budgeted. Let's say you budget a movie for 80,000 and you made, after that you made 200,000, means that you make like a 160% out of what you invest in that movie. So it's a good number to know. I think that those are the two key numbers that we can look at it here. Let's start with that. Let's do a markdown here on top. Let's do a feature engineering. And I call this feature engineering. It's because in the engineers, what they do is they do that. They build, they create, they form the formulas, the numbers, the calculations, or the data set in order for the analyst to analyze the data. So what we're gonna do, we are gonna look for the return on investment ROI. Let's create the calculation. Let's calculate profit, and then I think that these are the core business metrics to perform an evaluation, at least for this data set. So let's start by calculate the ROI. Data frame the ROI equal to, let's say, open parentheses, because we are doing a division here of data frame dot yes, but we'll do gross. And I think I add an extra here, minus data frame. Oops, that one is happening with me today. Budget. Then we close parentheses, the brackets, and then we have here. So we have the division done. Then we do divided by data frame square brackets budget. So divided by the column. And then because it's a percentage and we want to see any percentage, so we do that times 100 and they'll give us a percentage. So if I look for the entire data set, you look here, now we have the ROI here. The ROI it's 147. This is a percentage number. So when you're saying this, you're saying that if they budget for 190, I guess, $1 million, this is a million, and then the gross was 469. So that's a 147% of gross income. So they got more than what they do. If the ROI is negative, means that they didn't make money out of the movie, which it happens a lot. Let's see. The other one is, let's calculate the profit. Intelligence know what I'm doing. Jesus. Fine. So profit, and then equal to data frame. So it's gonna be the gross again minus data frame dot budget. So that's gonna give me the difference. And I'm gonna print head again just to show you. So we have the profit, and it's saying here that we have 2,799,800. Oh wow, it's 27,998,772. That's huge amount. The Shining movie. It's how it's called, by Stanley Kubrick. That's good. See, we are learning. That's a good thing about analyzing the data, because as we go and we are analyzing all this data, we are learning together. We are understanding what we are looking at. So it's really great. Now let's start. So we get all the measures we are needing. We know what we need. We have the formulas. We have all the columns ready. Let's start first with one of the most important things, and I'll do a markdown here. Let's do let's start with a two correlation analysis. What is a correlation analysis? So we're going to compute a correlation matrix. What is this? It will check all the numeric columns we have in the data set, and it will see if there is a relationship between them. We are going to identify strongest non-self correlations, like budget with profit. Let's say budget with gross revenue. Let's say that we believe that the more you put in your budget for the movie, then you will make more out of at the end in the gross revenue. And then after that this is the first analysis you're going to do. Then we're going to create a heat map for a quick pattern recognition. It's really good. It's really nice. We use it a lot in data analysis, and it's one of my favorites. So let's dive into it. So create a code here very quick. Let's call it correlation matrix equal data frame.correlate. And that's great. So you can do that one and it will work, but then you are going to get an error at the end. Let's say I'm going to print correlation and I try to do it and boom, I got an error. Why I'm getting an error? Because I'm getting all the data in the matrix. I'm getting all the data in the table. So for this one, we have to specify what we want to create a correlation for. And the easiest way is say numeric only equal true. That's the easiest way, and then we do, bam, we have all the data we are needing. It's not amazing. I do like this. So let's keep going. So we have our matrix here for the correlation. Now what we're gonna do is we're gonna look for the strongest correlations, because on this data set, it's, I mean, you can see, like, for example, year with year they have a 100% or 1% correlation, means that they are strong. But we have a score, it's 0.05, which is low, 0.2 votes, that's good, 0.3. So year it's hard, but let's look at budget. Budget, we have 1% of correlate, 1 point correlation, that's good. But then you see budget and gross, they have a 0.74 correlation, which is amazing. So we can look at that, but I mean, we want to be more precise. So I'll do another cell here, and then let's do a flatter correlation. And for that, we can do sorted pairs. So it's gonna be, and then we get the correlation matrix, which is what we have there, the correlation matrix. That, and instead of doing on stack, we're gonna do stack, and then we'll close parent. Then what this does is, let's print it out. Store pairs. Let's do head. Let's do 50. That way you know what I'm doing. So what we did is we turn everything. We are looking year, score, bots, budget, growth, runtime, ROI, and profit. So we have the data there we want. Now, from there, let's start filtering a little of data, because we don't want to be looking at everything. So I'll do, let's do filter and view only strong correlation. What it means is we're gonna filter for the strong pairs. So we'll do strong pairs equal, let's do sorted pairs. And then because we have negative and positive numbers, we are gonna do an absolute, and this is just for this, and we're gonna do an absolute sorted pairs. Now, if you don't know what an absolute means, it's like absolute will get all the numbers you have. It could be -2, -3, it could be 2 or a 3, and then we'll bring the absolute number of that number. So if for a -2, the absolute number is 2, for the 3 or for the 2, for the absolute number is going to be 2 or 3. So it's going to always bring the numbers to the positive side. So we're going to look at everything if the absolute number is greater than 0.5, which it's, how am I going to say, it's a great correlation. Then I like the other one, that will work, but I think I'm going to add a little extra filter to this. Let's see, let's remove everything that it's duplicate. Or so on this one, I'm going to open a parenthesis. I'm going to add this one has a parenthesis. So I want them to look at this one first. And then I also want, and in parentheses, let's go to the next line, sorted pairs 1. I think with that, what we are saying here is that we don't want the ones, like let's say this data. So year with year, we don't want to see that, because we know that year with year has a strong correlation because it's the same number. If you go to 2020, it's going to be a 2020. So it's the same number, and the system is getting everything has related. So we have that one there, and what we'll do is we'll remove these ones from here. And if we look at our data, which I think I have this extra here, let's see, sorted pairs, so strong pairs, boom. So we have both gross and everything that it's on top of 0.5, which is perfect for what we want. Something else, like I was saying before, that we may want to add here, it's a drop duplicates, and then we want to do a sort values in the ascending equal false. Let's do false, and then that gives us a shortest list. So we have gross profit has the top number 1. If we look at here, gross with profit, of course, it's a 0.98. That's great. Then we have budget and gross, but budget and gross here 0.74, which is, it's really amazing. So we have that data there. Let's keep that there. That way we can see those numbers in the future if we have to. And now to create a visualization, it's super simple, and that's why at the beginning we load this Matplotlib has PLT, and we also imported Seaborn because Seaborn has a correlation matrix or heat map that it works really good. Let's do it. Visualize the correlation matrix. From there, let's start with SNS dot. If you don't know what SNS is, well, you can look here. So it's a Seaborn. We use the alias SNS, and then we are gonna use a heat map, and for that we're gonna use the correlation matrix, double T or one matrix. And then we're gonna do anode equal true, and then format equal, it's gonna be, this is formatting for the text inside. We'll do dot. So we want to see with 2 decimal places, or maybe just 1 decimal place, what should be fine. And then from there we can do a comma, and then let's see SNA's heat map correlation. Let's select everything here. I like to do this way. See better here. So correlation matrix and annotation true, format one, that's good. Then we want to do a C map for that, and then we'll do a cool warm, perfect. I like that. It combines a little of blue and red and all that. So the C bar equal, the correlation bar equal true. We want the bar, and we want it square, of course, and the line width, let's say 2, maybe 0.4, maybe, and then we can close parentheses here, so 0.3 here. So let's hit this. Oh, CMap cool worm, it's wrong. So let's think about cool, what I have wrong here. So position argument follows a keyword argument. So it's gonna be heat map. Let's do heat map correlation matrix and a true. Then we do a formatting comma. Then we do a CMap cool worm. I think I spelled it right. The C bar equal true. Then the square equal true. And then the line width should be 0.3. Let's try that. There's something wrong there. Let's see. PLT does show. Okay, so I have something wrong there. Cool worm. Let's make sure I'm typing this right. Correlation matrix. That's the matrix. Annotation true. Formatting. So that looks good. Okay, I'm missing a here. Okay, I got an error. It's good. We are learning here, right? So we're doing SNED heat map correlation matrix. And a true format had 0.1. We got a comma, which is great. We do a C map cool worm, C bar equal true, square true, and line width, maybe let's line width with 5. So let's see. Heat map correlation matrix. Annotation equal true. Formatting, that's right. And then CMap cool worm. So same line, just in case it's something here. Nope, I guess. So let's see what we have. Quant mesh set, got unexpected keyword argument line width. Okay, I should have read this line widths. Lines widths, maybe. Now we have what else? Line width, line. Let's remove this argument very quick. See, okay, we got our number. Thought we have something like, let's try again. Line, did I was getting, yeah, I was line, line widths. Now it is. So I was missing the D there. So it's gonna be heat map correlation annotation true, C map, cool mark, C bar true, square true, line width 0.5. Let's check if will be line 0.2. Doesn't make really a big difference. So let's keep it on 5. And then perfect. I think that the other thing that we want to add, because there we don't know what it says. So pl2.title will be relation matrix heat map. That would help. And then for that we can do a little formatting. So we can do font size equal to 16 maybe. It has to be font weight equal to, let's do bold here, and then let's do font weight, and let's do a pad equal for 10. Let's see if that works. That looks much better. So we have a correlation matrix there. That's good. We can add the plt.show, which is good. Sometimes you see that it removes but if not, even you, because you're using a Jupyter notebook, even without using the plt.show, which give you the copy option on the save and all that, you can just do this without it, and you will get the same thing. It's gonna say text 0.51 correlation matrix heat map. So it's the same thing. So if you want to use in another layer, you can just always show. So I'll keep it that way. Then the next step, so we have that, which is it's good. Let's do it nicer, right? Because we are not here just to make things. So we have the heat map there, which is great. Then let's try it different. Let's try adding some theme color. We can try a navy color, and from this we can do I have some numbers here already pre-made, which is 002147. I like that navy blue. Let's add this here. Yeah, let's keep that, and then the theme color. I like that, and then I'll do the accent. For the accent bar will be number, and then we can do a 4C6 DAF. That's good. And then we have a background to give some color to the background. Will be we can do a number F5F7F6. I think that's a number F5F7F6FA. I'm sorry. So F7FA. Perfect. And then let's start creating. Maybe let's start with a figure setup like this, and then we'll do SNS style, because you just don't want to look straight from a system. You want to make sure what you do is not only good data, but it's presentable for what we are looking for. Does that make sense? So now let's work on the heat map. Heat map will be this, and then we'll do SNLS correlation heat map. For the correlation matrix, we can do this, and then we can do heat map correlation matrix. We can do annotation true. Let's clean a little bit this formatting. It's perfect. Let's CMap worm, or let's call it CMap. I define. No, I didn't define the CMap. Let's use a different color map here. Let's use a custom color map. Yes, because they have a CMap color map. It's a CMap equal SNS, the diverging palette. It's really nice. And then we have the 220. We can use this 15, and then we can do as CMap equal true, which is really good. And then for this CMap, instead of using the color one, which is it's good, but it could be better, right? We will do the CMap correlation, and then we have the C bar equal true. It's fine. The square true. It's good. Line width, we can leave it in 5. That doesn't bother me. And then for the annotation keyword, which is good because you see all this is kind of fit together. I start with, let's see if we can do an annotation keywords equal, and then we can do it. We can do something like, okay, for that we'll do a size. Let's try with a 9 first. Then we have color. Color could be black or navy. Let's try with black. We can change it later in the future if we want. Black. And then we want the weight, which is how it looks like. We want to see in bold. That should look good there. Weight, bold. Perfect. So we have that. Let's see if we can see it. We are getting invalid syntax, line width 0.5. We are missing a comma here. And then color right, weight, bold. I have another error. I love errors. So module Seaborn has no attribute style. Let's see what we're doing here, what we did wrong here. It's not a style, it's set style to white, and it's looking pretty good. I mean, from the past to this one, I see a lot of changes. I like it. I like what I'm seeing here. Then let's start now. We already added title, but let's organize. We need to organize our code. That way, if someone comes later, they know what we're doing. Labels. So PLT title, that's good. That looks good. Let's go to 16. Should be fine. Font weight bold color. We don't have color here. I love navy, so I'll go with color equal navy. Oops, I got an error here because it's not string. It should be a navy, comma. Oops, boom. I got correlation map to navy. That's why I set up that color there. And then the pad could be 20. Let's go a little bigger with the pad. That way it gives us a little space. That looks excellent. Now, like I was telling, now we have a little more space here. Let's clean a little bit the axis. Let's keep working on this. Do an axis styling, maybe. I think that's the proper word. Then we can do plt.xticks, and then we can do rotation equal 45. That will help. And we have that it's equal to right, and then we have maybe the font size equal to number should give to this 10, and then of course we can miss this color equal navy. If we try with that, boom, it definitely looks much better. Then let's look at the yticks, plt.yticks. Let's do the same thing for this one with you. Rotation equal 0, and keep that one. Rotation equal 0. That looks good. What I'm wondering is, yeah, it's not a 2 dots, it's an equal. Okay, and I'll do what else I can do for this one. We can do a font size equal 10, and then we have color, of course, equal navy. That should work. Boom. So we have everything. It looks much better now. Sometimes we like to, there is an option also that we use sometimes. It's called spine. It's hard to see it here. We may not need it. Let's see if it makes a difference. That spine left equal true, bottom equal true. I think that's what. So what we'll do is we'll remove all these two and we'll keep the other ones. We got an error here. What did Seaborn has no attribute spine, because it's not spine, it's this spine. This spine here, it's hardly to see here. I hardly can tell the difference, so I may just remove this one. But I wanted to show you. The other one, so we don't need the spine. We can look for the background. Looks good that way, but let's do a background. Let's do a background change. Background, it's equal to plt.gcf.set face color ground, which is the color we added here. Background. Let's try that one. I mean, it looks identical. Just adding a little extra layer there to look at it. It looks good to me. Let's keep digging. Let's keep analyzing. Now let's keep looking at our data. Let's start with more visualizations here. Let's start with a markdown cell. For this one, we'll do maybe core visualizations. And then from there, let's change this to Python. Okay, from there, let's start doing what we will do here. You know, we talk about the correlation between budget versus growth, and we talk about the correlation between votes versus growth. We talk about total gross by year. I think those are 3 really good visualizations we can use. We can work on those. So let's start with maybe 3 charts, 3 visualizations, one for budget versus growth, the second votes versus growth, and the third total growth by year, so that we can see how the growth has trended year over year. Let's start with that. We don't need to use the color palette because, or maybe let's create the color palettes again. Just I have the navy here, but navy, I have the accent, I have the background here. but I can use, because I'm gonna do a scatter. Let's do a scatter. Let's keep it in one place. So I'll add another color here, scatter color equal hash, and then we do maybe F2545B. That will be the scatter color. We hit enter, then we can start working here. So we don't need to add the palette colors here again. So let's start with the plot setup figure. That will be good. And then for the plot figure, fig size, let's say fig size equal, and then this is a tuple, should be 12.4. That should work. And then we have the DPI. It works. Sometimes we don't add the DPI. This is optional, but we add the DPI because it means that when you put it on a PowerPoint, or you put it in a spreadsheet, or you want to open it wider, you need to make sure you have enough quality or enough DPIs to make that bigger enough. So we create a figure, and then after that we can do an SNS.setStyle. This is something we used prior. The style for this one is gonna be white grid. Okay, so we have the white grid there. And now, so we create the plot setup. I think I should add a comment here. Let's say plot setup. So we have the plot. If you print this, you will get nothing. Plot is not defined because we don't have a plot yet. It's a plot PLT figure. So figure size, it's empty. We have a empty canvas right now, but that's what it's saying. And then let's start creating the figure. We do a scatter plus regression line, which is what we're gonna be looking at. Then let's start with sns.regplot, and then we open parentheses. And then for here, the first one we're gonna do is, I should have named this one. Let's do here markdown 1, 2, 3, 4, and let's do budget versus gross revenue. That way I know that I'm talking about budget versus gross revenue here. Then the first thing I'm gonna do, X is equal to budget, then Y it's equal to gross, and then the data will come from the data frame. That looks pretty good. Then from there, now the scatter, let's start cleaning the scatter keyword, words equal, and then let's start cleaning this a little bit. We can do color. I think we did the scatter color. Let's check very quick what we added here. Scattered color, perfect. So we have the scatter color, comma, then we have, we can also add the alpha, and the alpha it's because we want to make them kind of transparent. 1% it's full view, 0% it's not transparent, full transparent. And then this one, we're gonna make this, this is kind of a size, and we're gonna give it 35 points. This is for better clarity, will help a lot. And then from there, we can do a line for the progression equals to let's do the same thing. For color, it's gonna be, I call it accent. Let's do the accent. And then for what else? The line width will be 2.5. Let's see how that goes. And then, so we have that. And it should be, if we hit enter, we don't see anything. And here we'll see, okay, we have some data here. It's saying line 2D said got unexpected keyword argument line width. Let's say it's said got unexpected keyword argument line width. I'm always missing the D. With boom. So we have, it looks really good there. So 12/4, it looks good to me. Now let's start adding some title to this, title and labels. For that, we will do plt.title, append, and the title is gonna be, like I said, budget versus gross revenue. Then we can, let's see, I like to do this because it will look much cleaner. Then comma, and then we can do font size equal 18, comma. Then we can do font weight. Let's keep it here, font weight equal maybe bold. Yes, as a title always. Then something we can miss is color equal, of course, navy. And then the pad to get a little of space will be 20. Let's try with that. See how that goes. Budget versus gross revenue pad. Perfect. It looks amazing. I like it. And then let's go to the X label and the Y label. So we can do the plt.x label. And then we can do budget, we can do USD. You said the budget is in USD. Then we can do font size. I think we can use the same formatting. Font size, font weight, color navy. Yeah, let's use this too. Font size, boom. Let's try it. Oops, I got an error. X label, it's saying that text object has not property pad. Because of course it doesn't have a pad. Yeah. But so px x label budget, but I think that's too big. Actually, let's try with 12. Yeah, that looks much better. What else we can do? So let's go to the Y label. What I'm gonna do here is I'm gonna just copy this because it's what we did. Change it to the Y label. Gross revenue, the font size is gonna be the same, but I'm gonna change this to, this is gonna be gross revenue, USD, font size, and weight should be bold, color navy. That should work. Boom, it looks good, right? What else we can do? So we have the labels. Something we can do is work on the ticks to make it work much better. So we'll do let's work on the ticks. Styling. plt.xticks. We have the font size equal 10 and color equal navy. That should help. Navy. Then we have plt.yticks. We have same thing. We can do the same thing. And now let's do a little of formatting for both axes. So let's do it here. So I'll do format both axes in million. This is a good to have because millions. So we have plt.gca and then dot axis x-axis dot set major for matter, and then for there we're gonna use the function for matter, and then we're gonna use the lambda function. So lambda, for lambda we're gonna use x comma, we do this, so for this, and then we will do the formatting. So we'll convert all to string, and then we'll do a x, I think, dash 1 million 123 comma dot 0f, and then it'll give me the, after that I can get the $1 million formatted there. So I have the 50,200,350 million, which is, it's the number we are looking for. And then I think I'm gonna do the same thing for the y-axis. So formatted, and then we're doing the y-axis. Y-axis, boom. Oops, I got an error here. Y-axis formatter, what I did here. Oops, so what I got here, an error. Yes, I missed this here. Boom. And this one, I think this one is in $1 billion. So I'll try to add another extra here to see. So 2 billion, and then instead of million, it will be billion. 0 billion, 0 billion. That's too much. Let's keep it that way, the way it was before. Or we can do in million and then 1 decimal place. That will give us 0.0, 0.5 billion. 1 billion, 1.5 billion, 2 billions, and 2.5 billions. It's looking good so far. So far, it's looking really good. And then let's go to another one. It's gonna be, let's compare votes. I think votes, it's the other one. So we have here, we have budget and gross and profit, but then the other one is votes and versus gross. So let's start doing votes versus gross. Let's start doing it. I think I'm gonna use the same thing for votes. I guess I'll copy this. Let's work on this one and see if start from this one. That way we don't have to repeat the same code over and over. We can do votes in X and then gross, and then the same data frame, scatter, color, everything will be the same. Line 2.5, that works good. For the title will be votes versus gross revenue. That looks good. Font size 18, font size bold, color navy, pad 20. That looks good. Then for the X label will be number of votes, and then font size looks good. And for the Y label, it will be the gross revenue in USD again, which looks really good. For the X text, color size 10 and color navy looks good. For the Y format axis, I think I could keep I should do X axis. So this is for in million X axis. This is for the Y axis, but I should change it in the other one. Grid and border. Let's check. Let's change this one. Let's see how it looks like. Kind of look good, but we really don't need. For the gross revenue, yes. For the votes, I think I'll go without it. Let's see how that goes without it. Oops, this one, but no, I'll keep it. Oops, what I did. Okay, so I'll keep this. I'll format it. I think it looks what I'm doing wrong here. Oh, I missed it. Comment. No, la 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 la. But so 2 million votes, 2 million votes. I'll add it for this one. I'll add a 1 here that way. So we have 0.5 million votes for this one. It looks good. I mean, that looks really good. And it was, like you see, it was really fast to do that chart. It looks really good. Now, one of the good things or important things is we need to look how the business has gone, trending, like year over year data, things like that. It'll be good to look. So number of votes. Okay, so that looks good. So let's start with creating a trend chart. I think that was going to be good. So we can start with a data preparation, and then year trend. We need to look at the year trend is equal to, let's do a group by, just looking at the data. So let's see, we have the year here. What is the year? And we have the gross. So let's do that. Let's see how the gross in dollars have been growing year over year. So we can do a data frame.group by, and we can do year. So we want to group by year. Then we want to do a sum of a group of gross, and then it's going to be a sum, and then we will do a reset index. And then for year, we can do also, because if I think here, let's see, year trend, if I saw here, so we have from 9080 to 2020. But if you see there is a drop in, let's look at it first, because we have 2.2 here for 2020. Let's look at that. If not, we can. Sometimes when we are in the middle of the year or something, so the data doesn't show the entire year. So sometimes it's kind of hard to see it, and you see a drop in the line when it's not real. But let's look at that. So we would do it. Let's start with a theme, navy theme as always. SNet.set style to kind of like this style. It's the wide grid. Then we have the plt.figure and the fixed size I have been working with, and this is a tuple, should be 12 by 4, and I can add the DPI here if I want, which is 120. Then we finish the figure. We have the color. We have the color. It's gonna be navy. We don't have any highlight here that we can think of. Let's see. Let's start plotting. See if we need anything else. Plot. Let's do a plot. Plot. Oops. SNS.line plot. And then we will do X. Like we're checking. It's equal to year, comma Y equals to gross, and then we have the data. It's equal to year trend. That should work. Then for the marker, we can add a marker equal O, which will give us dot. I like those dots when in the trend lines. And then for the line width equal, I won't forget the D again for sure. I know I've corrected. And the color, I was thinking about doing the navy here. Let's see how that looks like. Maybe that doesn't work. We can try it. For the title, Let's start with titles. Let's see if how that looks like. Oops, we're getting an error here. White grid style must be on one of white, dark white grid. So I guess, so you see, as I was showing here before, so you have a drop in 220. That's because when they pull all the data, it didn't finalize all the data. So it's always good to correct that. And the easiest way to correct is you can set a maximum for the year and then that year drop it. But because I know it's 220, I'll just do a quick year trend equal to year trend, open a square, and then you do a year trend, then year not equal to, let's see, 2020, and that should help. Boom, we have everything but that one. That should help. And now that's kind of flat, so let's start adding titles and labels, titles, and labels. And for that, let's do a plt.title like that. So it's gonna be total gross revenue by year. That helps. And then the font size equal to 18. We wanted color, of course. It's gonna be navy. And then font weight equal, maybe bold. And then we have pad equal 20 to give a little spice to the title. That looks good. Excellent. Now let's go to plt.xlabel. Let's work on the xlabel. For the xlabel, we want the year. That should work. And then font size equal, let's do 12 to keep consistency. The font weight equal bold. Then we have the color, of course, color equal navy, because we already set up that. I mean, you can always organize this. I like that formatting, but you always can do it just in a one line sentence and build to the label. Let's clean this up just to show you that you can do it in a different way. And then you can do a plt.y label. Just, to me, it's how I get used to it. And I like all separated. And then for the Y label, we will do total gross revenue USD. That's it. And then if you look, boom, we have everything what we need there. And then let's do a little stylishing. Let's do a grid style. Then we can do a plt.grid equal visible, because we want to see the grid. Visible equal true. Command line style equal, let's do a dot dash, and then the line width equal 0.6. Then the alpha, because we don't want to see it too much, should be 0.6. That should give us, we got an error. Grid line width, always forgetting the D, width, boom. So we have the grid line, it went a little lighter. So you see this line here, that was what I was talking about a couple minutes ago. So here is a good example to use, maybe the plt dot the spine, and then when you the spine, I no attribute the spine because it's not the spine, it's this spine. It's not, it's SNS the spine. So we remove those, which are the most common. One other thing, we can change the color to the plt.xsticks. We can do the font size equal 10. Then we can do the color equal navy. That way we are consistent in what we are doing. Then I'll do the same here for the Y ticks. It's looking really good. Now, what else I can add? I can do a background. That's the plt.gcf, and then set face color equal face color is equal to background. Let's see if that works. Yes. Why background? It's because we already set up the background color. This one, we set up the background to that color. That's why I'm just calling up the variable that we already set up. Now, I would like to format the gross revenue, and I think I can copy the code from here. So we have gross revenue, font size. Let's do the formatting for the, it's the y-axis. Yeah, so I can use this same code here, plt.gca, and then do, just for not having to copy all that again. So come here and then do format y-axis in millions or billions actually. GT axis set major formatter, function formatter to lambda. Boom, 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 boom. That should work. If we see 0.5 billion, so that works. Then I think I'm gonna add another color because I would love to see this in a different color. Let's add here another one. I'm trying to put everything on the same place. So will be, let's call it highlight equal, then add another one here. Let's call it 4C6 DAF, 4C6 DAF. That will work. And then we can go here, and instead of having that line, we can do title, label, instead of color, let's do a highlight. Oops, I got an error here. It's saying that color supported are RGB to name it. Let's see what I get here. Boom, 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 boom. Highlight, and it's a 4C6. 4C. Oh, I have forgot the hash here. 4C6. Boom. Let's go all the way to the end. 4C6. Let's try now. But it looks kind of much better. It's lighter, and then you can keep the ticks and the text in the labels with a dark blue. That will make it much better. It looks definitely much better. Then let's start with a summary. We are almost done today, so it's been a long session. I hope you like it. Let's start with the summary statistics. Summary. Let's do a 1, 2 summary statistics. Then let's start adding a line of code. And here we're going to start looking at the data. So I'm going to do a data frame.head because I want to see the data. Then from there, I can start looking. So we have name, genre, year, release, name. Let's save name. Name could help us to know total movies equal. So total movies is equal to the data frame dot name. And then we can do a dot values count, and that not a values count, a count. And from there, if I see the total movies, it's saying that we have 5,421 movies, which is great. The other one we can see is we can look at the unique genres equal to data frame genre, and then we can do a drop duplicates. And then we can do a count as well. And we can see that we have unique genre. So what we got here, an error, count, not count. So we have 15 different genres. And the same way, let's see what else we can get here. Average budget, we can get the average budget equal to data frame budget dot mean. What else we can get? We can get, let's get the average gross equal data frame dot gross dot mean. What else we can get? Let's think about the ROI. ROI would be good to have the average too. Average ROI equal to data frame ROI mean. Then average ROI, and then we have talking about the strong correlation. Strong correlation. We need to talk about that too. So the strong correlation, I think we did this. So I think we are gonna access to this, and we're gonna get the first value with the profit to get that number. So let's go there. We're gonna do strongest correlation equal list. We're gonna do list is strong pairs dot index. And now look at this. So we're gonna do a strong list equal. Let's print this out. Strongest correlation, strongest, yes, I typed it wrong. So strongest correlation. So we have one gross and profit, budget gross, votes gross. So I have a list, and inside of a list, I have different tuples. So what I will do, I'll have to access to that. And here's the thing. When I create the correlations, we also create two columns. So what we are saying here is the gross and profit, they are correlated. And of course they are correlated because more gross revenue you have, of course, more revenue, more profit you will have at the end in the movie. But I'm gonna skip that one because I don't think that one it's very it doesn't say too much. But I think that budget and gross, it really does tell me a lot. Like saying like more I put in my budget, more I get in my gross revenue. So I'm gonna go here and instead of accessing to the first, which it will gonna be adding a 0 here, I'm gonna add the 1, and it's gonna give me the budget and budget and gross. That way I have a correlation. Then I'll, just to make it nice and more understandable, I do a line break. I like to do these line breaks. I learned this one a while ago, and it's just kind of nice. Oops, I got an error, of course. Equal, what it will do, you will see what it does. So now let's start printing this out, because we can print each variable, and so far what we have is the line break that there, but we want to make something nice because we have to report to our leadership. So I'll do a print statement 2, 3, 3, and then from there I'll start. Oops. Okay, so I have a print statement, and then I have the 2, 3, and then I have 1, 2, 3. So I'll start doing. First, I'll do my line break. You'll see how that works. Line break, line break. Then I'll do a summary, statistics, and then I'll do another line break. That looks good. And then for there, I'll start with, let's say, total movies. Total movies is equal to total movies. And then let's add a little formatting here, 0F. That'll help. And if you see what I'm doing is this. So strongest correlation, where I get it. Print, of course, it's not print, it's print. Line break is not defined. Break, line break. Let's see now. So it's working now. Then we have total movies, invalid format specific 0F. So we have the total movies. I have to add a period here. I think that's what I'm missing. Format fire missing precision. Let's keep that for the end. See if what I'm doing. So it's total movies 5,421. So okay, for that I can give a formatting like comma dot 0F. Let's see if now it works. Perfect. I guess I was mistyping something. And then I can do total movies, and then I can do unique genre. Genres, it's equal to, let's say we did unique genres, and then let's do the same formatting. Same formatting is gonna be comma dot 0F. Let's see how it looks like. It's looking good. So we have, and then we have average budget. So what I'm doing is adding all these details. That way I can have a really nice paragraph. Average budget. I can add the dollar symbol here, and then I can do average budget, then do the same formatting, comma 0F. You see, I had the average budget there. I can also add, let's type it. Let's type. So we have our budget. We need the average gross revenue. F, and then we have that one too, and then we can add the average ROI. It's the other one we add, average ROI. It's equal to the average ROI. It's in a percentage. So I'll do the keys, and I'll do average ROI, comma 0F, and then I'll do the percentage at the end. That should give me a 573% increase on ROI. What else we can do? We had the strongest correlation, right? So for the strongest correlation, we can do is strongest correlation. It's equal, then we will add a key here for this one. It will be strongest correlation. I think we said we will access to the 1 dot title, or to the 0, because we want to get to the first value, so we limited to the 1, and we want to access to that 1 to the 1 value, which is the name title. And then I close here and I say and. Let's see how we can do it. We can open here strongest correlation equal 1. I think I can use that, and I can do a title. And then for that one, I can close here, and then I can say with a correlation of, and then I open parentheses, curly brackets again, and I do strong pairs, and here's where I get the number. Strong pairs, and I'm gonna do a strongest correlation, those brackets, times 100, and then I'll format it as 1,01f. I close the curly brackets, and then I do a percentage. See how that looks. String single, f string single is not allowed. Let's see. So it's saying a strong correlation, budget and gross with a correlation, strongest correlation, budget and gross with correlation of 74. That's what I was looking for. That looks perfect. And then at the end, I'm gonna add, let's say I'm gonna line, let's do it this way, a line break times 3. That will give me, that should give me a really nice line. So what I'm saying this, boom, 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 and I'm saying, oh, total movies, unique genres, average budget, average gross revenue, average ROI, and the strongest correlation. That gave me data. That's really good. Something else that we can look at, and it should be very easy to get, we can do, let's say, what are the top 5 movies by gross revenue? And then for that one, we can start with, okay, top 5 gross, top 5 by gross equal, so sort values by equal, let's say gross, ascending, equal false, and then we want to see the head. So for there, when you print out, you can see now that, let's say top 5 gross dot head. What I'm having wrong here, frame sort values by gross, ascending is not defined. Top 5. Yeah, I understand now. So we have this, boom, we have the data, but we don't want everything. So let's start filtering this up a little bit. So top 5 gross equals top 5 rows, gross by gross equal to, let's say we want to see the name of the movie, the rating, we want to see the genre, we want to see the budget, and we want to see the gross. We can miss the gross. Also, something else we want to do is we want to reset index, drop equal true, and then head 5. Let's say only the top 5. So we have name, rating, genre, budget, and gross for the movies, which is really good. So we know that the top movie was the Avatar, then the Avengers with End of Game, Titanic, Star Wars movie 7, and the Avengers Infinity War. Those are the top movies. Then we can look at top earning companies by total gross revenue. So this is kind of the same thing. So we'll look at the top companies, but in this one, we're gonna do a group by. And here's the reason why, because we want to see the group by, we're gonna group by company, and we're gonna see the total gross, and then from there it's when we see everything. So oh shoot, I did it. So I mount the markdown file, I hit enter, and then I'll do a cell with code, and then top company group by, and I'm gonna group by company. Then I want to do, for gross, I want to do the sum. Then I want to do sort values at the end by gross, and then ascending equal false. And as always, we do a top companies dot head. Want to see the first top 5, and that should give us okay, we got an error. It's in series sort values got an unexpected keyword by. So sort values, I don't need this. So we got a company, or I can do this just to make it look much better. I can add this, and then is when I can do by equal gross. That will help me to convert to a data frame and looks much better. We have the company and the gross here. So we see that the Warner Bros is leading with $5.4 billion, I think it is. then Universal Pictures, Columbia Pictures, Paramount, and then 20th Century Fox, which is really nice. Name, I think I lose a camera. Now we are almost at the end of the season, so let's do another one. Let's do a markdown first to get the most successful companies, and is by average movie revenue, and then it's gonna be here. Let's do it 2 here. Most successful companies based on average. For that, so let's do most successful companies. Average gross companies equal, we can do data frame group by, then we're gonna do company, then we'll do a gross here, but then instead of doing a sum like we did in the previous example, we can do a min, and then we can do a sort values ascending equal false. Then with that should work. Let's say average gross dot companies, and we have all the companies there. Now what we want to get is, for the better visualization, let's convert this series to data frame, convert, and then we will do an average gross company. I'll copy this because I don't want to be repeating the same thing. Average gross company is equal to average company is dot reset index. Then we want to do dot columns equal company and average gross revenue. And then for this one, dot head, and boom, we have the companies, average gross revenue by company, and we have that Marvel Studio. It's, if we look at the average gross revenue, Marvel Studio is leading, then Illumination Entertainment, and then Fireview Entertainment, B24, and Arad Productions. Let's go to another one. This one is kind of interesting. That's why I look for genre. And genre, thinking about genre, we can say, hey, which genres yield the highest ROI? That will be a good question. Okay, which of the genres? So we can look at genres and say, this is a Python, so Python right here. Okay, so we can do a top genres ROI. That's good to know. The data frame is a group by, and we have genre, and then we can do ROI. Then we'll do aggregation. So we wanted to see what is the aggregation, and we can get for the aggregation we can get several things. We can get the min, and we can get the median. Those are the two that I think we will need, and then we can get we can do a sort values. We can do it by min, and then we can do ascending or false, and then we can print out top ref ROI dot head. Boom, we have that horror, family, thriller, animation, and drama. Those are by mean and by median, which is, it's really good. It's a good data to know. Let's see what else we can look at. The last one, and it's a good one. It's a good to know, and you will see that there is 2 directors that I think that they are the top notch right now. And let's look at top. Let's do it 2 top directors by best single movie profit. This is a good one to know. And I think we're gonna end our analysis. We have a lot of data here. I think it's been a good analysis. Let's look for the top directors. Data frame equal, we can do from the data frame, we're gonna look specifically to the director, comma, we're gonna look for the name of the movie, and we're gonna look for profit. Because what we're gonna want to know is what director make a movie, and we want to look at the profit that those movies they make, and what were the most profitable, and what was the director and what's the movie of that director. So we can get that, and then the other thing we can do is we will use the locate, and this one is a little tricky because we're gonna do locate, and inside of the locate we're gonna do a define data frame group by, and we will do the same. We'll get the director, and then we will do comma name, then after closing parentheses name. Perfect. And then we are gonna group by those 2, and then after that we're gonna do we're gonna get profit, and then we're gonna use the ID max, which is ID max is the index maximum. Then we'll close the bracket, and then we'll do sort values by equal profit, and comma ascending equal false. Then we can do end up with reset index. Let's do a drop equal true. And then as always, let's do a top directors dot head 5. So what we're getting here, we're getting an error. Okay. So it's saying invalid syntax. Let's review the syntax. Data frame, director. So we have that. It's good. Then we close that. So we pass a list. Then we do locate data frame group by. Then we do a parenthesis to group by, and we pass a list to the group by. And then we do the profit. We close the profit with imax, and then we close. Then we do dot sort values by profit, ascending, false, reset index, drop value. So that should be good. So let's see what we are having here. They can do, let's comment all this out very quick. This is way to, so by profit, so dot locate data frame, dot group by, that's good. Then we have this here, director name, and we have profit. Index max, here it's the error, I think. No, it's good. So we have close the values there, sort values by profit, comma, ascending, false, reset index, drop equal true. Let's see what we're doing wrong here. Let's analyze by part. So we have the group by, where we group by these two, and then we pass the profit, which is good. Okay, so let's sort values, profit, director name, and profit dot locate. Okay, and then this is what it goes inside of locate. I'm just looking at locate what are we gonna locate? We're gonna locate the group by. Let's do it. Let's check very quick here. So the easiest way to look at this, it's starting from inside to outside. So let's do let's check equal to data frame dot group by, and we're gonna pass a list. So we're gonna pass a list. We're gonna do director, comma name, and then we're gonna do a profit. Check. Place indices will be integers or slide string. Okay, so we're getting an error here. Display check. I'm getting something here. Profit dot sum maybe, and then we do a check. Okay, so I guess I'm having some issues here. Let's see, profits dot, well, that's why I have the imax here. So let's keep checking. I want to look at the index max, series group of those attributes, index max, ID max. Interesting. Profit, so locate here, locate max define. Okay, something is wrong here. Let's start from scratch. Top directors equal data frame, and then we will pass a list. We'll do director, comma name, and profit. Perfect. So that's the list. And then if we look at top directors that we have the profit, we also can do a sort values by equal profit, ascending equal false, reset index drop equal true. So we have the directors name, but sorted by profit. So these are the 5 top movies. These are the directors. That looks good. Then from there, we want to get, here's where it gets a little tricky. So even before the sort values, we want to do it. We want to locate data frame dot group by. Then inside of there, we want to get the director, and then we want to get the name. Then out of there, we want to get the profit profit, and then after that, it's when we want to get the index max should work. Okay, so now it's by index. We only have the top movies for each director. Now from there, let's do a top directors.head only to get the top ones, and boom, we have our data. Now I'm gonna clean a little bit this. I'll go to locate. Let's do this here. Then let's clean this up, and then mean profit locate. Okay, so oops, this one has to go together. Let's do it. Let's clean it here very quick. So that doesn't work there. Let's do name square brackets to get into profit here, and then yeah, that looks good. That should work. Perfect. Let's see. So, okay, it's been a long analysis. Apologize for the camera. What happened was that I guess the full battery, I need to get me a dummy battery where it charged the battery at the same time we were recording. But while I was recording, I didn't notice that the camera turned off because I didn't have enough battery. But now it's working good. Let's check very quick. We did a correlation matrix heat map. We did a budget versus gross revenue. We also did a votes versus gross revenue. We did a total gross revenue by year. And then in the summary statistics, we look a little bit for what were the total movies, the unique genres, the average budget, the average gross revenue, the average ROI, strongest correlation. We figured out that the strongest correlation were budget and gross with a correlation of 74.0. We also look at the top 5 movies by gross revenue. We look at the top earning companies by total gross revenue. We also look at the the most successful companies by average movie revenue. We look for which genres yield the highest ROI, and we ended up looking for what were the top directors by best single movie profit. And yes, friend, that's the wrap up for today's tutorial. We took a raw data set straight from Kaggle. We cleaned it, we shaped it, we explored it, and then we uncovered the stories hiding in the numbers. We saw how budget connects with gross revenues, how genres perform, and who is really winning in the movie industry. This is a powerful data, real, clear, impactful. Oh, and don't worry about the code. I've left a link in the description so you can follow along step by step. If you felt that spark today, hit a like. If you want more tutorials, more stories, more insights, hit subscribe and join the journey. Thank you for watching. Keep learning, keep building, and keep telling powerful stories with data. See you in the next one.